Oh, this one is interesting. How will Plutus support refinement types? A year and a half ago, Charles said Plutus would support refinement types, but I haven't found anything in the language on the design or implementation. Will it be integrated into the language or piggyback on Liquid Haskell, or will we end up with something like Liquid Plutus? Yeah, so refinement types are kind of an interesting concept. So for those who don't know, a refinement type is basically just a type, which is kind of like a thing, like an integer or a natural number, something, and it's combined with a predicate. And the point of refinement types is to assist with the process of program verification. So you have some idea of how you'd like your program to behave, and then you need to verify that it's actually behaving that way. So in practice, you're looking at things like buffer overflows, division by zero, maps missing keys. Some cases you can show that perhaps the program's not terminating, in certain cases. So there's little things you're looking for. And the point of refinement types is to give you an explicit way of building more complexity into your description of how things should transform, data should transform, types should transform in your program, so that you're actually able to verify that the program is behaving correctly. Now, this by no means is the only tool in the verification tool bag. In fact, formal methods is a very rich and beautiful topic. And our own Philip Wadler actually wrote a great book talking about it in AGDA, and I'd highly recommend it because I believe the book is free. There's also a great book from Benjamin Pierce, which talks about software foundations, and that uses a language called COC, which goes into exhaustive detail on many of these techniques that are used for formal verification. Now, it's a good question of whether we will support this and how will we support this. Perhaps the biggest advocate of it was someone who worked for our company named Rebecca Valentine. And she and others, like Philip Kant, were quite interested in Liquid Haskell. And we actually did pursue talent from perhaps working with Ranjit to working with Nikki Vazoo and others to try to build an agenda where we could upgrade Haskell to support refinement types in a native capacity. This is a very involved affair, and there's still a lot of friction and sharp edges with the use of refinement types. And over time, we determined that we weren't getting a lot of productivity with the concept in our own development workflow. So the question remains, does it make sense to write Plutus programs with these added types? And would that add value to the construction of Plutus programs? And honestly, it could, but then you also have to look at other techniques like quick check and model checking. You have to also look at just how you would write specifications and how you would standardize and design smart contracts, and perhaps in a templated way. And you go from the specification to the actual program. So this is a slightly more involved story, and it doesn't seem that Plutus 1.0 will support any notion of refinement types where it's at. Because the primary advocates of that approach years ago have since left and gone on to other things. B, we've learned more about how to write good smart contracting languages, and in our view, it's probably more prudent to focus on verification of things like Marlowe, where you actually can get very clear-cut answers because of the nature of that DSL, where you actually can use a SAT solver and explicitly show that things are happening. Whereas when you have more feature-rich languages, it's a bit more difficult to do that. So it perhaps makes more sense to express languages, express desires using as simple of a DSL as possible, and then that gives you a much lower chance of having bugs in your program because the language just simply doesn't let you do as many things as a full-featured programming language would do. Yet you're still able to solve the majority of things that you care about. So for example, the modeling of the movement of money is a super important topic. And if you can keep that as simple, understandable, and verifiable as possible, then all those classes of bugs that can result in the loss of money, the locking of money, or the incorrect balance of money moving would be completely eliminated, or at least greatly reduced. And then, of course, you could have some edge cases, and you can deal with those where and when they make sense. But this would be a great thing to think about in a more holistic sense for Plutus 2, something beyond 2020. So that's a very good question from Astral Emperor. All right.